Waves are literally everywhere, and they all speak the same language, math. So let's break it down.
They might seem totally different, but believe it or not, they all share one fundamental connection.
It all comes down to a universal language, wave equations. This is some seriously powerful stuff. So let's start simple. Imagine you flick a rope, sending one little pulse down the line. That's what we call a traveling wave. And check it out, it's described by this one elegant function.
So what does this all mean? Well, each variable represents something real, like position or speed.
Okay, the coolest waves are the ones that repeat, right? We call those harmonic waves.
First, you gotta know the wavelength. That's just the distance from one peak to the very next one. Then, there's the period. If you stare at one spot, it's how long a full wave takes to pass.
And frequency, that's just how many of those waves pass by you every single second. Now you'll see a few different equations for this. They all describe the exact same thing. And this phase thing, it just tells you exactly where a point is in its up and down cycle. But, waves don't just travel in a straight line. They move through 3D space.
First up, plane waves. Think of light from a super distant star. By the time it gets here, it's flat.
Then you've got spherical waves. These are just like ripples spreading out from a pebble in a pond.
So, plane waves are flat and stay strong. Spherical waves spread out and get a lot weaker.
So from a simple string to actual starlight, it's all the same math. Pretty amazing, huh?
But this raises a huge question. For light, what is actually, waving?